Good morning to all. Today we are going to know about topic in periodic classifications of elements. So introduction: the periodic classifications of elements, in which method by elements group or basic ether characteristics. We keep elements that are alkali and non-group and the rest of elements in the group. Next, we are going to talk in classifications of periodic table. They are in 18 vertical columns and 18 group in a long for periodic tables. So these groups are numbered from 1 to 18 starting from the left side, and then 7 horizontal rows called periodic in the long form periodic table. So the three major groups on the periodic table: the metals, non-metals and metalloids. Next, Mendeleev's periodic tables. The main credit classifying elements goes to resident chemistry for Dmitry Ivannik's, and then the most contributed yearly development periodic tables, wherein the elements are arranged by basis of the fundamental property, the atomic masses, and also similarly the chemical properties. So when Mendeleev started his work in 63 elements. Next, she is see there for periodic table of the elements. Next, Mendeleev periodic tables. So noble gases are like helium, nitrogen. So have been mentioned many group of context before these gases discovered very late, but concentrations is very atmosphere extremely known concentrations. So once again, the strength Mendeleev's periodic tables was that when these gases discovered could be placed in a new group without distributing extents ordered A. Next, limitations of Mendeleev's classifications. So, electronic configurations of hydrogen resembles that alkali metals. So, like alkali metals, hydrogens, oxygens, sulfur, and then compound having similar formula. So, compound of helium, HCl, H2O, and then H2S. So, compound of Na, so NaCl, Na2O, and then Na2S. Next, the modern periodic tables. So Henry Moseley, 1913. Atomic number of the element is a more fundamental property is the atomic masses. So according to Mendeleev periodic table law, is the modified to atomic number was adopted to the basis of the modern periodic table. So modern periodic law can be started as follows. Let's recall the atomic number given the number protons, nucleus, and then atoms. Number increases by one going to from the element to the next. So arranged order of increasing atomic number. Let us classification of the periodic tables. Next, atomic size. Uh, the atomic size refers to the radius of the atom. So atom size may be visualized. So atomic size, visually outmost of the cell is isolated atoms, and when down in a group, an atomic number increases, cell numbers increases, and then radius increases. So examples for lithium, beryllium. Next, chemical bonding and molecular structure. Chemical bonding and molecular structures what let lasting attractions between atoms, ions, molecules, and enables chemicals for compounds to form. So enable chemicals form two examples: hydrogens, heliums, oxygen. So H2O, anything for elements for between atoms and molecules in enables chemical compounds of the form. So ionic bonds to form the electroelastic force attractions between oppositely charged ions, while covalent bond and formed by the sharing of electrons. Next, causal leaves approach to chemical bonding. So, in case bonds formed to H2, F2 in etc. bondings, electron between the atoms. In case of each atoms attain stabilized outer octal of the electrons. So, outer octal in the electrons can be least simples in the formations of the molecule. Only outer electrons balance, and then electrons take part in chemical bonding and hence are called valence electrons. So electrons has the sp f orbitals, so not take part in chemical bonding. Only d orbital take part. Next, covalent bond. Covalent bond is Lagnier refined the least protective including introducing the term covalent bond. So the covalent bond is formed the sharing of electron between cells or subcells and then two atoms cells. So next you can see the covalent bonds. So atom 1, atom 2, non-metal and non-metal or metalloid. So next covalent molecule. So next formula charge. So formula charges means can be defined as the difference. So difference between valence electron the atom isolated free state the number of electron assigned to atom the least structures. So formula calculating charges formula can be atoms F equal to C, total number of electrons in the free atom, and then total number of non-bonding or lone pair electrons, and then half total number of bonding or shared pair electrons. Next, bond parameters. So bond parameters. Bond length. So bond length is defined as the equilibrium distance between the nuclei two bonded atom in a molecule. So in the case of covalent bond and contributions from each atom is called covalent radius in the atoms. So covalent radius is measured approximately radius atoms which can contain core of adjustment in the bonded situations. Next, you can see the bond angles. So linear, trigonal, planar, tetra, octahedral, trigonal, bibrium materials. So you have to many materials bonding in the angles. So next, redox reactions. Redox reactions which be oxidations or reductions chemical reactions in which reactants undergo change their oxidation states. So redox reactions that means oxidation stage change their oxidation states. The term redox is a short form reductions oxidations. All the reactions can be broken down into two different process in reduction process and then oxidation process. Next, types of redox reactions. They are different types of redox reactions: decompositions, combinations, displacement, disproportions reactions. There are many different types. I will choose this in the four different types. So you can every different types of in the redox reactions. So I will send the four different types. So loss of electrons for oxidations A plus B, so equal to A plus B. So you have to apply the gain of electron reductions. So you have to gain two electrons reductions. And then real life use of redox reactions, you have two protections. Importance chemical is also based electrolysis which is stands is based on redox reactions. Many chemical like caustic soda, chlorine and produced using redox reactions. Oxidation reduction reactions also for the applications starting water bleaching materials. You can doing to apply the redox reactions was you have to real life using the redox reactions. You have to apply in bleaching powders from and then protected for corrosion connecting from the sacrificial anodes and undergo corrosion instead. A common example technique of glavinations in the steel. So you have two glavinations in steel work out in the redox reactions real life used. Thank you, students.